Hello friends, my name is Rohit Karse and I will presenting the topic Bayesian classification. So I will cover the following content. The first one is the Bayesian classification. The second one is the Bayes rule. I will explain how it works with the example and how it is related to the Bayesian classification. And the latter we will conclude it with the following manner. So, the Bayesian classification is the classifier of the family of simple probabilistic classifier based on the applying on the Bayes rule with the strong independence assumption between the feature. It is really important because it doesn't have iterative parameter estimation. It is not complicated. It is just simple. So how we'll find out the Bayesian classification? The first there is the classification is derived from the maximum probability. The formula is given, right? Probability of x belongs to the I, where C represent the classes and x are the vector. The simplified assumption is given below. That is probability of x. Uh, x tends to the C and equal to k, pi of the k. Next is the Bayes rule. The Bayes rule is defined by the probability formula like p probability of h by d, where h is the hypothesis and d is the data. So it is the probability of the h by d, how we will define, which is equal to the probability of h multiplied by probability of d into h, that is the likelihood, and the prior probability um, divided by the probability of d, which is the independent probability of d. Next, now we will see the example of the Bayes rule. Let us consider lamp producing factories. There are the three factories A, B, C. The total production of the A is 0.35 percentage of whole production. The production of the B is 0.35, and the production of the C is 0.30. So what will the probability is also given that the probability of defective lamp from the A factory is 0.015, and from the probability of uh, factory B of the defective lamp is 0.10, and the factory C is 0.020. So how we will find out the probability that the lamp was manufactured in the factory C? So we will find out using the Bayes rule. Here is the simplest formula for the Bayes rule to calculate the probability. So if we combine the probability of C and D and divided by the probability of all defective lamps, then we will find out the final probability by 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 calculating the all the probability in the manner. We will get the final answer 0.047. So this is how we will calculate the Bayes rule. We will calculate the probability using the Bayes rule. Next we will see the classification of the Bayesian classification example. Consider there are total number of 60 objects. 40 of them are green and the 20 are them of red. What would be the color of the newly inserted objects? So if we insert the new white object in between these all the object, how we will know what will be the color of the that. So let us consider that object is the X. So for that we have to calculate the other probability for the green and the red. So we will calculate the prior probability of the green, that is 40 by 60. 40 are the green object and 60 are the total object. uh, Same we will calculate for the red, 20 by 60, that is the, and we will also calculate the likelihood of X, that is the newly inserted object given by the green. So it will be the 1 by 40, and likelihood of X given by the red, which is equal to 3 by 20, because we will consider the nearest element for for to calculate the likelihood. So to get the posterior probability, we will have to multiply the prior probability and the likelihood. So for the posterior probability of X being green is the 1 by 60, and the posterior probability of X being red is 1 by 20. So we will see now that X is the red element. If you see, there are 3 red elements are more compared to green. That's why we will make that element as red. So this is how we will conclude the naive Bayesian classification for the to find out the probability of element. So we conclude that based on the independent assertion, the training is very easy and fast. The test is also straightforward. If we compare the generative classifier model, the performance of navigation is competitive. It has many successful applications like spam mail filtering and the brain tumor in the medical department. But there is one problem in navigation, that it doesn't deal with the dependencies. For that, we have Bayesian belief network. So this is how the naive Bayesian classification work. So I refer the main paper, reference paper from the washington.edu, and these are also the reference where I made the paper presentation. I refer these links to make the presentation. Thank you.